We're not live yet. Now we're live.
Oh, you heard it here first.
We had it first, yeah. So hello everyone. This is Entree Live. My name is Chris Grice, the host today. I brought with me today one of my friends and colleagues, Matt Adam. I'm gonna let Matt introduce himself, but he's been a colleague of mine for some time now. But I'll let him introduce himself. Go ahead, Matt.
Hey guys, Matt Adam, longtime user of Avi. I think I started using Avi back in 2015 or 16 on the customer side, and then ended up coming to VMware, and then just recently left to go to a startup and came back. So I'm in a new role now, a product manager role, specifically for the AKO piece.
Yep, thanks for that, Matt. So yeah, Matt is, everybody probably knows Bhushan, but Matt is the new Bhushan, just for everybody's future reference.
Exactly.
This side. But yeah. So today what we're going to do is got a couple of topics actually to cover today. Or obviously sort of around Avi, AKO, various things like that. First of all, we're going to have a look at NodePortLocal. We're kind of going to look at sort of what it is, why it's good for Avi, why we're going to use it, and then I'm going to do a little bit of a demo. We're going to deploy an application, scale it out, and we're going to see sort of how NodePortLocal works, how it works from a Iptables perspective, how it looks on the Avi controller, that type of thing. Then we're going to have a quick look at sort of future state of AKO and Istio. We're going to see sort of, we've got some quite exciting integrations coming. They're sort of beta in the next release, but GA coming after that. So we're going to look at the first phase of that. And then we're also going to have a quick chat about Terraform and Avi as well, how you can sort of automate the Avi controller and all the various pieces that go into that, the Avi cloud, and how we can tie that into sort of TKG, etc. So yeah, that's about it. So quite a bit to cover, but we'll get through it, I'm sure. So first of all, I'll kick off with some sort of NodePortLocal stuff. And I will share my screen. So this is going to work first time. Can you see my screen? It looks like you can.
Yep.
So first of all, what I'm going to discuss is kind of from an Avi perspective. Why do we need NodePortLocal? What does it do? So initially, if we kind of look at what NodePortLocal does, and I'm looking here at just the Entree docs. NodePortLocal is a feature that runs as part of the Entree agent, and fundamentally, what it's doing is it's exposing a backend pod, very much like kubproxy exposes a pod. But what it's a little bit better than it's much better than kubproxy, because it's what it will do is it will expose a pod on the node that the pod is on, and it will give it a unique port. So this gives us quite a few advantages over kubproxy. kubproxy, of course, as everyone knows, exposes a pod that's across all nodes on one port, and then so any traffic going into that sort of node port will be feasibly load balanced by kubproxy to whichever pod. And so we can't control things like persistence and things like that with NodePort, but with NodePortLocal we can. And that buys us several advantages with Avi and AKO. And so what I'm going to do is I'm just going to go through some of the sort of common routing scenarios that we use for AKO, and then we'll jump into sort of NodePortLocal. So as you guys probably already know, one of this kind of differences between Avi as an ingress controller and a traditional ingress controller is that the ingress controller itself is on the service engine, and the service engine is sort of outside of the Kubernetes construct. It's outside of the pod networking fundamentally. So this poses a little bit of a problem, right? So if the ingress is outside of the cluster, how do we get traffic back to those pods that are within the cluster? And normally, not all the time, there are some instances where this isn't the case, but oftentimes your pod networks, they're unroutable to the rest of the network. And those pod networks could be used in multiple different clusters. For example, here we've got one example. I've got a cluster on node 1's on 192.168.1.0, node 2's on 192.168.10.0. Those are my two pod networks, and then my nodes are 10.10.1.1 and 10.10.1.10. Now, how does the Avi service engine talk to those unroutable networks? Well, basically what we do is we apply, we deploy the Avi service engine, L2 attached to the Kubernetes nodes. And what the AKO operator will do is it will read the pod siders on the node spec. And basically what it'll do is it will create routes in the service engine that basically say, hey, to get to this pod network, go via this node network. And you can kind of see that there. Now, one of the downsides to this is that if we have multiple clusters and they all share this same 192.168, say this is a 192.168.0.0/16, all of my, say I've got 10 clusters and they all share that network space as a pod network. This is going to pose me some routing problems on my service engine, because my service engine is now going to have a load of next hops for the same network. So the way we get around that is what we'll do is we'll provision a service engine group per Kubernetes cluster. And then each service engine group will have its own routing table fundamentally. So each service engine group would have the same sort of destination network, but it would have the node network as the next hop address. The node IP, sorry, of each cluster as the next hop address. And this works great if you've got like large clusters, and you might actually have a service engine group per cluster anyhow, if you have very large clusters, because you'll need to do that from an SSL termination perspective, things of that nature. However, it can be a bit problematic when you've got lots of little clusters, because you may not need all of those service engines. Basically, it may prove to be expensive. And Zinky's on. How do I show that again? Hey, Zinky. So what that means is, so if we don't want to have a service engine group per cluster, we got two options. First option is NodePort. So we can expose our services with a NodePort, and this does work. And the pool members in this case, instead of on the previous slide, the pool members behind the Avi service engine were the actual pods. In this instance, the pool members are going to be the NodePort port and the nodes. So this does work, but the thing to remember here is not everybody wants to expose their services with NodePort. You can exhaust the NodePort ports, and also fundamentally you're relying on kubeproxy to really load balance to the various different pods. Because we're sending the traffic to the NodePort sending it to kubeproxy is doing whatever it does. Now you can do things like session affinity and things like that. So session affinity you can apply that in the service, and that will ensure that the traffic goes back to the same node. But what happens if there's more than one pod on that node? There could be 3 pods on that node, and you could have 1 pod on another node, and you're going to be splitting your traffic unequally. So then that brings us to sort of the third option, and that's the option we're obviously talking about today, which is NodePortLocal. And so what NodePortLocal does is it's a feature, obviously, as we said before, it's a feature of Entrea. And as I was saying, what it'll do is it'll expose that pod on that node on an individual port. So in this instance, you can see, my application green pod here. It's exposed on the node, and it's exposed on port 40,000 in the case of node 1, and on 40,001 on node N. So you can already see that there's a difference there between sort of NodePort and NodePortLocal. And if I had more than one pod on node 1, for example, say I had my pod was scaled out to 3 or 4 pods, and I had, 2 on node 1, 2 on node 2, then each one of those pods is exposed would be like 40,001, 40,002 on node 1, and then 40,003, 40,004 on the other node. Now, as you can see, there's quite a few advantages to this. Number one, we don't have to use NodePort services. We can use cluster IP services. We don't have to share service engine groups. We can have one big service engine group, so we can share service engines across all clusters. And additionally, we can health monitor and we can persist to individual pods. So those are all the the good features. It's a really great feature to use, especially when you're combining Entreya with Avi and AKO. And specifically sort of with TKG. TKGM is a great use case today. We try and use this as the default methodology for your CNI and also your AKO service type. So did I miss anything, Matt? Do you see anything I missed?
No, I mean, and this is like a stupid newbie question, but are we worried about like the 65,000 limit for ports? I mean, do we ever see clusters with more than that in pods?
No, and it can be extended as well. So this in this instance is 40,000, right? But you can actually change that value in the config map or the values, the Entreya value. It's not the Entreya value. I think it is. Whatever the config file that you configure Entreya with, you can also change it there. So if you were concerned about exhaustion, and if you remember, this is on a per cluster basis. So here you're talking about sort of 10,000 pods, which is a
quite a bit. Yeah. Okay.
Quite a big cluster. But if that is a worry, then you obviously can do that. So next steps are like, what do I do to enable NodePortLocal? And it is, let me have a look at it. So this has changed a little bit. So initially what you had to do is enable it in the feature gate. So in your Entreya agent conf, there is a feature gate which you enable. You just change it to NodePortLocal enable true. And that is it. I think that's what you have to do to date. It might actually be enabled by default now. But this is if you're doing Entreya on vanilla K8 or something like that nature, or it could be EKS, wherever else you're running Entreya. But if you are running Entreya with TKG, then what you do is when you're building your sort of YAML file to deploy your TKG, the TKGM, this is specifically, all you need to do is just in this file have this Entreya _ NodePortLocal true. And then from an Entreya perspective, that's really all you need to do. And then the next thing you would do is you can either set your, there's another field you could put in here, which is AKO service type. You can either set that to NodePortLocal, or you can actually configure the ADC. So if you're going to use ADCs, AKO deployment configs for your workload clusters, you can manipulate the AKO for all ADC, change that to NodePortLocal, and you can, that's how to enable it from an AKO perspective. And I can actually show you that as well quickly. I think I can anyway.
So is this supported pretty much in all the TK in the Tanzu products right now?
I don't think I mean, obviously Entreya is, but I don't think TKGS ships with a TKR Tanzu Kubernetes release high enough to support Entreya out the box. To support NodePortLocal. But I've just jumped over to my management cluster. This is the one. I've called it install AKO enable layer 4, but this is really layer 7, sorry. But this is really you can see here. So this is my ADC. This one's enabling ingress, but you can see here I've just changed the service type here to NodePortLocal. And then the clusters I've actually, because I've only got NodePortLocal enabled on one of my clusters, which is this one here, NPL-AL. So I've labeled that particular TKG cluster with this enable layer 7 NPL. So that's what that's doing is it's then configuring the AKO on that cluster. The AKO operator is configuring the AKO on that cluster to say use NodePortLocal. And so that's how I would enable NodePortLocal on a TKGM workload cluster. So what we'll do now is so this is what I'll do now is I'll how this actually works is what Entreya is going to do is it's going to configure an Iptables rule, and basically it's going to do a DNAT rule on Iptables. So I'm logged into my one of my nodes now, and so I'm just looking at the Iptables chain for NAT. I'm looking at NAT, the chain for Untitled and NodePortLocal, and you can see here there's nothing there, and I don't actually have an app deployed yet. So what we're going to do first is we're going to deploy an app. We're going to see what happens on Iptables, then we're going to see what happens on the AVI controller, and then what we'll do is we'll scale that app out, and we can sort of see what happens on the Iptables and see what happens on the AVI controller as well. Just make sure I'm in the right directory. So another thing that I'll touch on, we'll have a look at that as I deploy the app as well, is what will happen is Entrea is actually going to tag the pod and the service. The service it's going to tag with a NodePortLocal enabled, I believe it is, and then the actual pod itself, it's going to put in the translation. And when we deploy it, we'll have a look at that, and that's how AKO reads it, and that's how it reads those particular pieces. So just a simple, I've got a deployment of service. It's a secure ingress. So I think it's just one replica set, but we'll soon find out. Watch, it won't work now.
Got to get that license.
Don't say that. What is wrong with it? So did this? Oh, I tell you why. I'm in the wrong. I'm going to deploy ingress on my management cluster. Don't do this at home. I know what I'm doing, honest. I do. So if you get to your right cluster and then you apply it, there we go.
Is there any way we can zoom in and make the font just a bit bigger on the CLI?
This one here?
Yeah.
Yeah.
There you go.
Is that any better? I was trying to get all three in because I was trying to be fancy, but I guess I don't need to. Let me do this one too.
That'll work.
So now if I come back to my fancy AVI controller, we should see the ingress now, and there it is. So basically what happened, you can see down here, I made a deployment that has a pod in it. It's just a web app hackers on. We did a cluster IP service. My ingress is secure, so I've got a secret that's hold my certificate and key. And then I've also configured that ingress. And so now if we go look at the sort of Iptables, you can see now that we now have a DNAT rule in there too. And you can see sort of, we're saying source anywhere, destination anywhere, but the TCP destination port, if we're coming in on port 61,000, we're going to NAT the destination IP address to 196.1.21, and we're going to do a destination NAT on the port to port 80. And so if I then go kubectl get pods minus wide, you can see that that's this address here. So 196.1.21, and the service is listening on port 80. But if you do kubectl get endpoints, which is really what we're looking at, basically this is what we're doing that DNAT to. So externally is exposed on 10.206.114.53 on port 61,000. Entree is pulling the DNAT to say, hey, NAT that from port 61,000 to the pod IP and the pod port. And so what I also wanted to show was if we actually look at the service that we span up there, and you can see sort of what Entree is labeled here, annotated, sorry. Scroll up here, you can see, yeah. So what it's done is on the service is added this annotation here, NodePortLocal.Entrea enabled true. So the cool thing about AKO's implementation with Entrea and NodePortLocal is it does all of this for you. If you're doing this without AKO, then you have to enable it. You have to add these annotations yourself, but AKO will actually do this for you. And then if I go look at the pod as well, well, if I come up to the annotations, I can probably do this in a cleverer way, but you can see here, so it's basically annotated the pod saying, pod port is 80, node IP is the node IP, and then the node port is 61,000. And that's.
And did you say it adds that marker somewhere on the SCG or on the SCs themselves?
No, it basically annotates the service in the pod for an Entrea. Is what it's
okay, so this is strictly in Kubernetes. Nothing actually goes to Avi on that.
No. Because if you think about it from an Avi perspective, Avi's just routing to this here. So it's not really conscious of anything that's going on. AKO is telling it to use this port, and then that information is coming from here, and the IP tables are all. So what I will do as well is we'll just scale it out to say 5 replicas, and we'll just sort of see how quickly we react to it. So we just put on. Before we had just 1 replica, and I've only got 1 node. So if I was using NodePort here, even though I'd have 5 replicas, I would only have up here. You can see how quickly Avi's responded to that already. But if we were doing NodePort, there will still just be, even though I've got 5 replicas, even though they're on one, just because I've got 1 node, we would still only have 1 pool member. Because it's just 1 node port. All of those pods would be behind the same node port. But here you can see they're not. We've got multiple pod members. They're all on their own unique port. So you can kind of see the advantage there. So you can see that Avi has, responded to that very quickly. We've scaled out. And then, of course, if I go look at my IP tables again, you can see that it's written all those IP tables rules. And if I go look at my endpoints one more time, you can sort of see that these are in here as well.
Very nice.
So that's fundamentally how it works. It's quite advantageous to us as sort of people that sort of sell Avi, market Avi, etc., because it really helps us get around that service engine good question, because that can come up quite a bit. If you have like a smaller customer that has lots of smaller clusters, they may not want to have 2 service engines, 2 service units per cluster, because it can get quite expensive. Yeah, so that's really NodePortLocal.
It's been informative. Appreciate it. Yeah, a lot of this is still kind of new learning for me.
Yeah, as I say, I mean, anybody, if you can use it, use it. And there are some with TKGM. This is the one I go with because it, it's the best method for us. And the guys that wrote AKO sort of came up with it, and it matches our use cases, really well. So
for everything on Treya, NPL. Gotcha.
Yeah,
you heard it here first.
With Avi, anyway. With Avi. Yeah. So yeah, that's the NodePortLocal piece of today's.
So circling back real quick, the limitation you had mentioned with TKGS is the Entrea version that's used in the supervisor cluster?
It's the one that goes onto the workload or whatever the guest clusters. The Entrea version that ships with the Tanzu Kubernetes release that goes into TKGS doesn't have a high enough version of Entrea. So I don't know if I covered this at the beginning, but NodePortLocal was it was an alpha feature in 0.13, and prior to 1.4 you had to enable the feature gate. So I don't think it was, yeah, so it graduated to B2 and 1.4. So it's not available. I forget what the Entrée version that ships with TKGS is, which TKR, but last time I checked, you couldn't use it because it didn't support this level of Entrée.
Okay, and it's not something you can upgrade directly?
My understanding is it's not, obviously not in the MapBU, so I don't know exactly. But last time I was looking at this with a couple of colleagues from the MapBU, and the last time we looked at it, you couldn't do it. But you know, things change, and you know, so. But it's I've mainly seen it used to a TKGM.
Okay. Very nice.
Cool.
All right. Any way to see if see who's in the chat and see if they have any questions on it, or is it kind of a one-way feed from them?
There isn't any questions. Can you not see the chat? I don't know how I share the chat with you. There was hello, yeah. There was 2 hellos.
Yep, I see those. I can't respond to any of them.
We don't let you say anything there. Sorry. Good.
Probably should have created an account.
Oh yeah, so yeah, could you zoom in a bit? Yeah, I didn't see that. Sorry. Yeah, so I guess we'll talk about Istio on next. Let me get deck out. Can you still see my screen? Yeah.
Yes.
I'm assuming you can see that, right? Istio proposal.
Yep.
Yeah, so I wanted to kind of talk about this. This is a little bit into the future for AKO, but it's kind of a really cool thing that's coming down the grapevine. We are going to be sort of offering, you know, in AKO 1.8, we'll be offering beta release for the phase 1 here, and then hopefully it'll be GA 1.9. Don't hold me to those release dates. Hold Matt to them.
Yeah.
Definitely don't hold me to them. They might get pushed, but this is definitely coming. When exactly is, you know, things happen when they happen. But so, you know, it's going to be a really cool thing, and a really cool thing that I think that will set sort of Avi and AKO as an ingress controller a little bit aside from everybody else. But I just wanted to go over it quickly, and then we're going to have a quick chat about Terraform as well towards the end. But, you know, I'll keep this pretty high level, and we'll keep it on like how Avi ultimately is going to integrate here. But, you know, ultimately, what is Istio? Istio is obviously a, you know, it's a service mesh. It's basically injecting a sidecar proxy in between your pods, and all traffic from the pods is routing through that sidecar. In this case, it's Envoy. And because of that, you know, we're pushing all the traffic through Envoy. We have an Istio control plane that can, you know, can program those sidecars to really do, you know, Envoy is a really pretty powerful proxy. So Istio is able to sort of, you know, configure Envoy pretty much how we like. And so we can enable sort of MTLS. We can put authorization policies in there, network policies, routing rules. We can do all of those cool service mesh pieces, and we can, you know, Istio enables us to do those with Envoy. Where the Avi piece in particular comes in is north-south. So, you know, when we think of a service mesh and we think east-west, that's not where Avi's going to come in, but we are going to come in from a sort of north-south piece. And the great thing about that is that we're going to be able to sort of enable WAF and SSL decryption and encryption, all that type of thing from a north-south perspective. So that's going to be really cool. And so how that is basically going to be working in the end is that we're going to be and again, remember, this is sort of a future case, but we'll be replacing sort of Envoy on the edge with Avi service engines. And then once we can replace Envoy at the edge with the service engines, we can, you know, we can bring all the power of Avi to that north-south traffic flow. So WAF, network policies, analytics, you know, as probably everybody knows, Avi has really cool analytics and logging so we'll be able to bring that to service mesh, to bring that to north-south providers. So that'll be quite exciting. And the sort of first phase of it is going to be sort of integration with MTLS. So of course, one of the problems is when you're running Istio, you want it to be secure. That's one of obviously the great advantages of service mesh. And Istio accomplishes that today with MTLS and sort of spiffy certs. And so one of the problems that we faced was how do we integrate AVI, AKO, and the service engines with Istio's MTLS functionality. And because the service engines themselves are kind of outside the Kubernetes infrastructure, we can't just deploy like an Envoy proxy on the service engine and say, be done with it. So initially what we're actually going to do is we will run, so this is some of the challenges here, but what we intend to do as a part one process is to actually run an Envoy proxy, an Envoy sidecar on the AKO operator itself. And so what will happen is Envoy will pull the certificate down from Istio-D, and then AKO is going to pass that up to the service engine via a secret. And then we're going to be able to configure that sort of PKI profile on the service engine, and then we'll be able to have north-south encryption to Istio. And the cool thing is we'll be able to have strict mode on. And again, as I say, we'll have WAF and we'll have all the layer 7 analytics and visibility that sort of AVI brings to the table anyway, which we usually do for ingress and things of that nature. We'll be able to bring that to Istio as well. And of course, there's a lot of Istio use cases out there. And then ultimately, this will also extend to sort of Tanzu service mesh as well. So, there's going to be that, very much better together story with Tanzu service mesh as well. So kind of covering this quickly because it is sort of future state, but I did want to sort of bring it to everyone's attention that, anybody who's watching this is that we will have a pretty cool integration with Istio pretty soon. And I think it's going to, make the AVI and the AKO product pretty strong and pretty cool.
Yep. And as you said, we're targeting 1.8.1 for kind of the beta release for that, which has a kind of release date of late October, early November timeframe.
Yeah.
So more to come on that.
Yeah. Yeah. And it's going to get more involved as well, isn't it, down the road? I mean, I'm not sort of probably bill after the end of the year kind of thing, but sort of one. Are we going to 1.9.1 or 2? Is it going to be?
I think 1.91 by end of year. That's the goal.
Okay, cool.
Mm-hmm.
Give me 1 second. Yeah, so looking forward to that. And, we've had a lot of requests from customers to support Istio and service mesh in general. And so, that's going to be coming.
Yep. Well, thanks for that little tidbit.
Yeah. I've lost where the chat is too. I'll get that back in a minute. So I guess we can now talk about some Terraform.
Oh boy.
Yeah, AVI and Terraform. So I guess we're going to assume that everybody knows what Terraform is. I'm assuming we do, but if you don't know, Terraform is a way to sort of provision infrastructure declaratively. And
there's a couple use cases for it. Yeah, I mean, the infrastructure is definitely a good use case. I would say lately I've seen even more of a push for application configuration and software configuration, which is surprising because that's kind of always the bread and butter for Ansible, or Salt from back in the day.
Yeah, I'm kind of surprised to hear that too, because I mean, from my perspective, I would always use it to, bring up infrastructure, then use Ansible to configure the infrastructure. That seems to be the easier. You're
absolutely right. That's what I saw trending in the industry for quite some time, and then, especially in the last year or so, I've seen. You have some organizations that hate Red Hat, and you have some that only want to do Ansible. It's confusing to say the least, but I think the push in the industry is that Terraform is used to spin up the infrastructure, and then Ansible would be used in conjunction to configure the infrastructure. It doesn't have to be that way. There's a lot of modules, including the Avi Terraform provider that we have now, which will actually let you spin up configurations. So you can quite literally go in, declare all of your virtual services, declare any pools that you have, VSVIPs, as part of basically the Terraform object. And if I could share, let me see if I can take over the share.
Yeah, let me stop sharing.
Share screen. Okay. Let me know if that comes through.
There we go. Add to stream. I've always got to remember to do that.
All right. So what we're basically looking at is the Terraform registry, and after you've installed Terraform on your jump box or wherever you're planning on using some Terraform, you'll need to call in the appropriate module that we're going to be using. So the provider in this case that we're talking about, there's the VMware provider, there's an Avi provider, which I think is this one right here, the Avi provider. And I'll show you some examples of what you can do with them. In fact, there's a simple example here, but you can basically create these objects directly. So there's a number of ways you can create things in Avi specifically. One of the major benefits of Avi is that it's an API-centric product. So quite literally everything you do in the UI is tapping into the API in the background. We have APIs that are specific to each object. So if you want to create a virtual service, if you want to create a pool, if you want to create a health monitor, there's an API for that. And we also have macro APIs, which you can kind of use to control all of it at once. So if you want to have just a one-stop shop JSON blob to go and create your entire application, you can do that as well with macro APIs. Similarly, you could also use Terraform. So the reason why I brought this up is, when you first do your init, you declare which provider you'd like to use. In the case, of Avi, right? We'd use the VMware Avi provider. And then at that point on, you can start sending configuration. So you can declare an entire blob of configuration to be sent to Avi. So this is where it's slightly different than Ansible. I would say that they're both declarative, but in the sense with Terraform, you basically have one large file or multiple files that contain all of your configuration, and it's all pushed at once directly to the controller. Let me pull up an example of here's some examples of the Avi provider itself, where you can actually go in and whether you want to deploy the controllers to public cloud or you want to deploy an object. This kind of comes back to what Chris was talking about. If you want to use Terraform to go in and deploy Avi controllers and service engines, you can do that, and then you can stop right there. Or you can use the Avi Terraform and then continue to use Terraform to deploy all of your configuration in it. So I've got a couple things I want to show you. One is that this was actually built by a colleague in Avi here, where basically it does all of your public cloud and on-prem deployments of Avi. So you set up a variable file with your vCenter creds, your AWS creds, and then what you want. So multi-cloud, do you want a Gslb cluster? Do you want this cloud configured? Do you want service engines of this size, right? You put in some basic configuration, click go, and then, or rather apply. And then at that point, Terraform will go in and create all of the objects for you. It's slightly different than the Terraform provider Avi, which this is the one that has the ability to come in and create objects as well. So let me just click on virtual service so you can kind of see the format of one of them. We'll do a simple one, HTTP. So there's a couple of different files that you normally have in a folder when you do your Terraform init. The primary being main.terraform. So this is where you're going to have all of your provider information. This is where you'll have all of your resources, any data that you have. And then you also have kind of a variables file. So this will be where you would declare login credentials. You would declare information about the VIPs you want to create. Basically any of your config, and then output. So this is exactly what it sounds like. Anything after the object has been created that you want to know about. So if you're deploying Avi in a public cloud, one of the things that you might want to know about is the ephemeral IP address, right? You want to know how to access Avi after it's deployed. Or if there's a virtual service, maybe you want to know the VIP IP pool, maybe you want to know the backend pool member, something like that. And the files themselves are incredibly simple. So as you can see, if we pull back up the Terraform provider Avi, it tells you exactly what you need to do. It says, hey, put this little config object in the top of your main.terraform file. And then what that'll do is that will go out and it will download the content directly from Terraform, and it will store it in basically the module for use. And so you can actually come in and you can create some new data objects, and you can create your resource type. So in this case, we're doing an HTTP VS, and we're creating basically an Avi Cloud. Looks like it is creating an Avi Cloud in this one. And then it's also coming in and creating some profiles, some string groups, some application profiles. And then of course, here in just a second, virtual service, we'll see the virtual service resource object here.
Right at the bottom.
Right at the bottom, yeah. So it's doing the full thing here. It's coming in and creating some pools, pool groups, some of the different templates that you would need to create the application itself. And then the last piece of it is quite literally going in and creating that ingress point, that virtual service.
I think one of the things to touch on as well, Matt, is sort of how the API interacts. So like sometimes you'll have nested blocks, won't you? So for example, there you've got that virtual service HTTPS, and then within services, you've got nested port and enable SSL, but there can be a couple of nested sort of structures there, can't they? Like if you look at VIP, you've got VIP ID and then IP address. And I think the thing to note there is that you're putting those from if you want to know how those work, you can put them from like Swagger and the Avi controller, or you can just look at the API, and it's basically going to follow that same format.
Actually, that's a really good point. That's generally how I build my Terraform out. I think that's the easiest way to do it is, you could definitely go through the docs. I think the docs are pretty intelligent, and you could look through and find the exact, parameters that you need to build the object. But just as you said, it's sometimes just as easy to go into an Avi controller, create the virtual exactly how you want it, and then go to the API itself and look at what was created. That way you can, it's basically the same format as well. You can copy it and then dump it into your resource for like pool group or for virtual service. And then you have a working example of how to recreate that. It'll change a little bit because some of the syntax here is not exactly JSON, but generally speaking, it's kind of one for one there. The other thing that I was going to talk about is that, so this is a very simple example, and I know it may look complex, especially if you're new to Terraform, but this is a bare bones example on how you can create different resources using a simple Terraform script. But as with everything, you can make this as complex as you want it to be. And so one of the other modules that I was going to kind of just do a quick glimpse on, I won't get into how it was built or any of the intricacies on it, but this module actually uses Ansible in conjunction with Terraform. So there's a couple of these. So this is Terraform AWS Avi ALB deployment, written by Sean Larimore. And there's a couple. There's GCP, there's Azure, there's vCenter. I think there's one with NSXT Cloud as well. And what they do is they allow you to deploy Avi in all of these environments with kind of a one-click button. So if you're trying to create Avi in AWS, the normal route is you'd go to EC2, you deploy your EC2, you wait for it to boot up, you log in, get the password, create your account, and then go through and configure your cloud, all the network settings, everything. With a couple, a couple inputs in a variables file here, you can have all of that done for you automatically, right? This is especially useful for POCs, home labs, or any type of environment where you need to test versions or anything like that. What were you going to say, Chris?
Yeah, so one of the other cool things that he has in this is that you can actually do a multi-site GSLB deployment with this as well. So if like you're new to Avi and you've heard about GSLB and you're not quite sure how to set it all up, then you can come in here. He has a really, on his actual provider, on the Terraform page, I don't know if it probably is in here actually. I haven't looked at this because this was recently uploaded, wasn't it? It
was, yeah. It is going to be in here as well. I could probably pull it up in here.
But it has a, you can do a multi-site setup, so you can do, and actually deploys an application with a GSLB virtual service. So if you're like new to Avi and you want to see how GSLB works and you just want that quick, easy button to get it going,
search for
Sean's modules here are very good. But he's actually on my team too, so I can harass him. I can't really, but you know.
There you go.
Again.
Yeah, so here's the example of the AWS one. It's quite impressive, you know, when you think of what all goes into creating a controller and then creating all the objects on it. It's impressive not only that we have a colleague that built this, but even more so that this can be done, right? You know, the days of having to go into your environment and you know, do something manually before something can be automated are kind of going away, as almost everything nowadays can be automated. And I was joking with Chris before the show started that that I've got a smaller home lab. I've just basically got 2 servers, and you know, if I want to do different configurations, if I want to do TKGI, or if I want to, you know, do TKGM or something else, right? I kind of have to spin down my environment and then rebuild it. And to do that manually each time would take me half a day at least to, you know, to do some of those environments. So I've automated all of them, and that's an example of something you can do with your home lab environment as well. If you normally go in and configure NSXT and all of these additional settings just to get something working, consider automating it, right? Terraform would be great for that. I know Ansible has a very strong presence in NSXT and vCenter as well, or rather the entire vSphere suite. So you could definitely use Ansible. Terraform works as well. So the piece that I was going to show you here, though, let me pull it up here. I believe it is in the file section. Okay, awesome. So let's circle back real quick. So I'm going to pull back up into just kind of one of these. So let's do network here. So earlier when we were looking at kind of the format for a Terraform directory, right? You have, you know, you have your main.terraform, you have outputs, you have vars, but quite honestly, the names don't really matter. What matters is what you specify and what type of object you're wanting to output. So if you want an output, you put an output. If you want a data or a resource, you specify that type of the object in here. What he's done is he's essentially created all of these different individual files so that you can, you know, whenever you go into it, you know exactly what section of the Terraform will be created in there. So outputs.terraform is going to have anything that's pertinent to, after everything's created, what you want to see. So IP addresses, public and private, any information about the controller as well, tagging. And then if you went to something like IAM, right, you would expect to see strictly, you know, RBAC controls in here, or you would see users getting created, certs getting created, things like that. You know, network in this sense, right? This is going to be part of the network configuration that's required to go into AWS for spinning up VPCs, which will be used back into Avi, and then also subnets and any IGs that need to be created as well for internet connectivity.
So, and I have a silly question as well. But is he calling all of these for main.tf, or are you running these all when you do?
Nope, main's most likely just the provider information.
Yeah. So then you would either have those modules in there or not when you did Terraform Apply, basically. So if you didn't want to do IAM, you wouldn't have IAM. And yeah.
Exactly. So if you were trying to run this on your own machine, and I probably had it, you know, I probably could have mocked this up to show you how easy it is, but it's as simple as just a git clone, download all the files to your folder. You're going to come into this directory. You're going to pull up the variables.tf file, and you're going to add in some information. So some keys, so you can get access to AWS, you know, the keys that you want to use for the VMs, just some basic information about your environment. You know, do you want to create networking for you? So, you know, this module has the option to do all of your firewalling, all of your networking for you, so that you don't have to go in and create your own VPCs. But you also have the option to, you know, BYO VPC, where you can do all of your own networking and you just set this to false and create some more input, some more variables for it. And after you've done that, quite literally, all you have to do is Terraform init to download the provider, and then it's Terraform apply, you know, -f, right, or Terraform apply auto approve, and at that point it will go into AWS, pull out the marketplace, load up the image, and then start configuring all of the environment for you. It is quite simple to use. That's one of the reasons why I love Terraform, is you don't have to have any dependencies on your local machine. You know, you don't have to make sure the packages are correct like you do in Ansible, or that you have the right collection. You basically just do a Terraform init. It'll download everything it needs from the provider, and you apply it. or you can do a plan, and it'll tell you what it would have created.
Yeah, so we have these for, as you were saying, AWS, Azure, GCP, vSphere, and I think you said NSXT as well, isn't there?
Mm-hmm.
So pretty much every flavor of cloud we have available. Yeah. When would, I mean, and this, you're a bit more advanced at this than I am. When would you use Ansible? I mean, for me, it's just Ansible for the configuration. But if I'm using Terraform to create virtual services, how does that kind of, because if I want to update that virtual service, right? I mean, what does that look like? How does that, and I'm just kind of having the conversation.
Yeah, no, definitely. And you kind of beat me to the punch. So I said all that as kind of a precursor to say that in more complex Terraform configs, you can actually use Ansible in conjunction with Terraform. And that's essentially what Sean's doing here in this repo, is he uses the Terraform to go in and create all the networking objects, the firewalls, anything needed in IAM, the actual VM itself for the Avi controllers, or multiple if it's a cluster. And then all of the configuration piece, that's actually done in Ansible. So I'll give you an example of how that looks here. So I'm pulling up the EC2 -Avi Terraform. He's got some local local variables that he's basically pulling from that vars file, and then it goes through some basic configuration. But if you look at this resource right here, AWS instance Avi controller, right? This is the instance where he's actually coming in and he's creating that particular EC2, and he's basically deploying it. A little bit further down, so after we've deployed the instance, we're gonna do a little bit of life cycle here, making sure that it comes up, waiting for it to get an IP address, right? So basically saying wait for it to get an IP address, and then at that point we're doing some basic tagging. But the piece where the Ansible kind of starts to kick in is right here, where you have this null resource. There's a couple of different ways you can run null resources, but in this case right here, what he's doing is he's essentially copying the Ansible file from this files directory, and he's moving it over to, and in fact, I have an example of it here. He's basically copying it from the templates directory and moving it over to the Avi controller. So Avi basically already has everything you need to go ahead and deploy this configuration. So he's using some templating as well, which I won't get into right now because it's kind of a little bit more of an advanced concept. But he's essentially taking the YAMLs file, deploying it directly to the Avi controller, and then running it. So all of those configuration items that we had talked about already, spinning up your cloud, creating the service engine groups, sizing the service engines if you needed, adding licensing, creating your first VS so you can have a service engine deployed. All of that is something that you can actually automate directly in these Ansible files, right? And I'll circle back and show you an example of one of the Ansible files here. So we've got some templates. The templates is so again, it's currently named .tpl. What he's doing is he's injecting variables in here, and then he's renaming it as a YAML file. And that YAML file is the one that will actually be running. So if you look at it, it's for all intents and purposes, it's a YAML file. It's basically something that you would run in an Ansible -playbook, the typical Ansible file. The only difference is that he's able to inject variables in here through his templating. But basically, it's going through and it's creating all the different objects. Create firewall rules, add your DNS server. He's looping through DNS search domains. What else is in here? So he does a little bit of configuration for the Gslb piece, and then he has a little wait time in there. And he's basically going through all of the steps that you would have done manually when you pull up that Avi controller and go in and go through each of the different wizards to create your cloud, to create the initial screens. And he's doing it for you through automation. It's actually quite impressive. Yeah, I'm impressed by it, Chris.
I'm
I love this stuff.
He actually did this when we did the VCM bootcamp. He did a automation demo, and so he kicked this off at the beginning of the demo. At the beginning of the talk, we had like 45 minutes to talk to VCM guys, and then like 20 minutes in, it was all built, and he had like this full sort of multi-cloud Gslb demo. And it was built in the background while he was talking about automation. And so it really it was really quite a powerful kind of, like this is how easy it is. You guys have no excuse.
Yeah, no, it definitely is.
He does make it seem easy, but it is, it is straightforward. And Avi's really, it lends itself well to it, doesn't it?
As someone who's automation focused, right? It's, you have to look at the tasks that you have at hand and make decisions of, is this worth automating? Is this not worth automating? Am I spinning up an Avi controller once every 3 months? maybe it's not worth, or maybe once a year or something, maybe it's not worth automating. But if you're in the environment where you like to test new code, or especially if you're at an enterprise and you have Avi running in production, it's probably beneficial to have some type of script like this, so you can go and spin up the latest version of Avi, download your config from production, drop it into your sandbox environment, and test it. See if everything loads. See how the objects handle the newer version of code, and then tear it all down with the Terraform destroy, right? Whether you're deployed in a public cloud or on a a vCenter environment, this can save you hours. I mean, this could save you days, especially if you're only configuring Avi once in a blue moon. Some of those settings might be foreign to you again. Create it in Terraform, save the variables file for the next time that you have to deploy something in Sandbox, and you don't have to worry about that again.
Yep, very nice. Very nice indeed.
Yep. I love automation.
Yeah. Yeah. So we are, I think we're about at time, really. It's 4:56. So I want to thank you for coming on, Matt. That was great. Thanks for the Terraform bits there. And
yeah, I'll shoot you my mailing address so I can get one of those cool shirts. Wear it instead of my Avi shirt.
You're not going to get one. So
it's part of the in club. I'm not in yet.
It is. Yeah. You don't know what I have to do.
Yeah, I don't want to know what you had to do.
Anyway, yeah. So thank you. Appreciate it. And I think that's it. Thanks everyone for listening.
Cool. Thanks, guys.
Bye.